Section 5.1 is about verifying trig identities. So what are trig identities? Trig identities are very similar to solving a puzzle. You're trying to verify the left hand side of the equal sign with the right hand side of the equal sign. So what you want to do is work one side of the equal symbol, not both at the time. Other than that, there are no rigid rules for the process. Okay? Before this, we talked about the unit circle and we created all the different relationships that we know. So, what are some of those relationships that we talked about? Here are some of the fundamental trig identities that we mentioned before this. So, if we remember, sine can be defined in terms of a reciprocal, which is 1 over cosecant. Okay, which is 1 divided by cosecant of x. So we can rewrite sine of x as 1 over cosecant. Then cosine is the same thing as 1 over secant of x. Tangent is the same thing as 1 over cotangent. So the idea for this first set of identities is that we use the reciprocal. The reciprocal just means flip the fraction, right? 1 over some value to recreate whatever's on the left side of the equal symbol. We're just rewriting that identity. Next we have cosecant, and cosecant is 1 over sine of x. Next we have secant, which is 1 over cosine of x, and then cotangent is going to be 1 over tangent of x. So those 6 identities that we have there so far are called the reciprocal identities. And the idea is that whenever you encounter maybe 1 over cosecant, that you can identify it and rewrite it as sine of x if it helps simplify your problem. Okay? The next 2 identities we have are quotient identities, or just a ratio of 2 things, right? So the definition that we know for tangent is sine of x over cosine of x. So you can rewrite sine over cosine as tangent by itself, or if ever you have a tangent in your expression you're trying to simplify, you can rewrite it as sine over cosine. Cotangent, being a reciprocal of tangent, is just the flipped version of it. So cosine over sine is the same thing as cotangent of x. The following identities that we have here are already defined, but what I want to talk about is perhaps trying to rewrite them in a different way. So sine square plus cosine square is equals to 1. It's our main definition in terms of Pythagorean identities. You can also rewrite it in different forms. You could say sine square of x is equals to 1 minus cosine square of x, or cosine square of x is equals to 1 minus sine square of x. So don't be limited by just this definition that you're given, right? You can also rewrite it in such a way that you can use that definition in many different ways, right? So you may be wondering, do I need to memorize all of this? And the idea is yes, you may need to use variations of these fundamental identities like I just showed you here, right? I simplified or rewrote this definition in two different forms, right? So it is important to know each relationship well so that you can manipulate it algebraically, like rewrite it in a different form, but still following the fundamentals of algebra, that if you move one thing to the left, you're subtracting or dividing. Whatever you would do for solving an equation, you're pretty much doing the same thing here in one way or the other. The last part of the identities that we have, it's called even or odd functions, or even or odd identities. And that's simple. It is just saying that if you have sine of a negative angle, it is the same thing as negative sine of that angle positive. These are good to know, but they're not hugely popular in terms of the problems we do, but it's good to understand them. One example that we'll do here is the following. We want to verify that secant of x times cotangent of x is equal to cosecant of x. So what I was telling you earlier about trying to match the left-hand side with the right-hand side is that you only want to work with one side at a time. Don't try to make changes on both of the sides at the same time. So pick one side and work with it individually. Okay, so for example, let's work on the left side because it seems like it's more complicated. So what can we do? Well, let's try to write secant and cotangent in terms of sine and cosine. So I'm going to work on the left, and I'll let that kind of signify this, right? That I'm modifying the left-hand side, and I am doing secant is the same thing as 1 over cosine of x times what is cotangent? Cotangent has a definition of cosine over sine. And if you notice here, we have two things that are multiplying to each other, and their diagonals are equal to one another, meaning cotangents cancel out. And then I have 1 over sine of x, which in terms it's the same thing as cosecant of x. And I just shown that the left-hand side is equals to the right-hand side. So in this type of problems, the work is very important. How you show your steps is crucial, right? Because it doesn't matter whether you say yes, they're equal, or no, they're not equal. You have to show how they're equal to each other. Okay. Here are some pointers as to how to solve this problem. So one method is to separate fractions. So you want to separate them into a single term fraction. In other words, if you have this, for example, a plus b, and it's all divided by c, well, we could break it up into a over c plus b over c. What does that look like if we were doing trig functions? Well, for example, we have 1 plus sine divided by cosine. What we can do is separate it over that plus, and we have the following. We have 1 over cosine plus sine over cosine. And this is just the example we're trying to show, right? We can split this fraction and perhaps have more leverage to simplify things. And the second method, or the second pointer that we can always use, is changing things to sine and cosine. So if you have a tangent, rewrite it as sine over cosine. If you have a secant, then you want to rewrite it as 1 over cosine. You know, whatever other identity that we see, we want to be able to rewrite it perhaps in terms of sine and cosine. And that is everything for verifying trig identities.